So with 7-1, we were multiplied and divided. With 7-2, we're going to be adding and subtracting. So what we have to do is think, when you add or subtract fractions, what do you need to get? You need a common denominator, and we're going to have to do the same thing here. So that's called your least common multiple, but we're going to be doing it with polynomials. So to find the least common multiple of 2 or more polynomials, we're going to factor each polynomial. The LCM is made up of the greatest number of times a factor appears in at least one of the polynomial's prime factorizations. So what you do is you take each separate term and you break it down into the prime factorization. So 15 a squared bc to the third. Well, that's 3 times 5 times a squared times b times c to the third. 16 b to the fifth c squared is 2 to the fourth times b to the fifth times c squared. 20 a to the third c to the sixth is 2 squared times 5 times a to the third times c to the sixth. And then for the LCM, what you have to do is you have to go through each term, separate terms, and circle the highest power of each factor. So 15 has no 2's, 16 has 4 of them, 20 has 2. So I need the highest one. I need 2 to the fourth. I have 1, 3 for 15. I have none for 16. I have none for 20. I need that 1. I have 1, 5 for 15, none for 16, 1 for 20. I need one of the ones. Doesn't matter which one. For A, I have 2, 0, or 3. I need 3. For B, I need 1, 5, or 0. I need 5. And for C, I need 3, 2, or 6. I need 6 of them. And then your final thing is what you're going to do is you're going to multiply those numbers out. So 2 to the fourth, 16, times 3 times 5 is 240. A to the third, B to the fifth, C to the sixth. And there's your LCM. Now, that happens if you have monomial terms. If you have polynomials, you got to factor them. So first part is if I take this one, I'm going to factor out an x, which leaves me with x squared minus x minus 2, but that's not totally factored. So then I get x, x minus 2, x plus 1 for that term. X squared minus 4x plus 4 is x minus 2x minus 2. So I'm going to put those together. That's an x minus 2 squared. So now my LCM, I have 1x and no x's, so I need an x. I have 1x minus 2. I have 2x minus 2's. I need 2. That's why I combine them. And I have 1x plus 1. I have none. I need that x plus 1. And then you don't need to do anything else in terms of rewriting. That is what the LCM is in any order with that, but the x should come first. So when we add or subtract, the first thing you got to do is you have to find the least common multiple for these. So again, with fractions, you have to find, it's sometimes called the least common denominator, least common multiple, same idea. So if we look at 16b to the fourth, that's 2 to the fourth times b squared. For the second denominator, we have 5a to the third b. So that means our LCM needs 4 2's, a 5, 3 a's, and 2 b's. So that's 80, a to the third, b to the second. Okay, so what I'm going to do is rewrite my two terms, and I know that I need 80, a to the third, b squared in both of those denominators, because that is going to be my final denominator. So then what I do is I look at my original denominator for each one and my LCM. To be honest though, I would look at the factored one in terms of the prime factorization because it's easier. And you say to yourself, all right, well, first of all, let me add, I originally had 3a squared and I originally had 8x. Now I got to say, all right, well, what's missing? So I have 2 to the fourth, so that I have. So I'm going to use green here, and I have 2 b's. So I need 5 and I need a to the third. That's what I'm missing. For the second one, I have the 5, I have the 3 a's, but I have 1 b, so I need another b. So I need 2 to the fourth times b. So 3a squared times 5a to the third is 15a to the fifth. minus 8 times 16 is 128, and bx. So you're looking for what is missing in each denominator to get to the LCM. All right, we have 6b, so that's 2 times 3 times b. 14 is 2 times 7, a squared, b squared. So my LCM needs a 2, a 3, a 7, 2 a's, and 2 b's. So that's 42 a squared, b squared. So I have my denominator. I have my original numerators. And then I'm asking myself, all right, well, what is missing? So I'm going from here to here. I have 2, 3, and I have one of the b's, which means I need another b. But I need a 7, I need a squared, and that other b. For the second one, I have the 2, the 7, so I need a 3. I have the 2 a's, and I have the 2 b's, so I only needed a 3. And then when you distribute 5a squared, 7a squared b, that gets me 35, a to the 4th b, and 9 and 3 make 27. All right, let's keep going. Now we're going to start with some polynomials, though. So when I factor the first denominator, I get x minus 3, x plus 2. Second one, I get 5 and x plus 2. So in my LCM, or LCD, either one, I need a 5, I need an x plus 2, and I need an x minus 3. So let me set it up. So that is my new denominator. These actually, even though they're harder, I guess, with the factoring, they're easier to see what's missing since you already factored it out. All right, so I have my original numerator. Okay, so I have this, and I'm going to this. So we ask what's missing? Well, I need a 5. Second one, I have this, and I'm going to this. What's missing? I need an x minus 3. So I'm going to have to distribute the 4 in the first case, and I'll have to distribute the 5 in the second case. So when I do that, I get 5x minus 5, negative 4x plus 12, and then this is when you're going to have to write it one more time. So it's x plus 7 over 5, x plus 2, x minus 3, final answer. All right, so far you've only had factoring ones with a coefficient of 1, but realize you are going to get ones that don't always have a coefficient of 1. So just review how we factored with those in the past with previous chapters. But if you look at this first denominator, we're now looking for two numbers that multiply to get 20 and add to get 21. After you use whatever process you use to factor those, you get 4x plus 1, x plus 5. For the second one, take out a 3 with a 4x plus 1. So your LCM needs a 3, 4x plus 1, and an x plus 5. So let's set up. Here's our LCM. So we have a 6, so we have an x minus 8. And now we ask ourselves, all right, what's missing? I'm going from this to this. I need a 3. I'm going from this to this. I need an x plus 5. And what you could do is just distribute it above it so you don't have to rewrite a whole nother step. That might be a little easier. So you get 3x minus 24. And again, we're adding here, so nothing sign-wise is being affected. So you get 9x plus 6. And then just always be careful. You have 9, 6, and 3, which are all divisible by 3, so you have to make sure that you cancel and simplify. So even though we thought we'd get away with simplifying at the end, you're not. Everything should always be reduced completely. So there's your final answer. All right, the last and final one here is these are complex fractions, and it just means you have something going on in the numerator and something going on in the denominator. So what I would do is I would treat them separate. So if you have 2 over x minus 1, do that first, and then do the denominator separate from that. So with the numerator, we see x is our one denominator, and this one's 1. So my LCD is x. So to save a little space, I'm going to add an x here, and I'm going to add an x here. So my numerator is really 2 minus x over x. That's my numerator. I'm going to do the same with the denominator. So my denominator, my LCD is x times y. Well, here I need an x, and here I need a y. So I get x plus 3y over xy, and that's my denominator. And then it's telling me I'm dividing them. So what I'm going to do is write them horizontally. 3y over xy. We know we can't divide fractions, so what I'm going to do is flip the fraction, multiply, and then flip the fraction. And then what you find is the only thing that cancels are these x's. So we have a y with a 2 minus x on top and an x plus 3y on the bottom. But I do suggest treating the top and bottom separately and then putting